Question 1 from 2022 IEB paper 2. A jewelry manufacturer measured the diameters of 400 gold spheres produced by machine A and another 400 produced by machine B. The results are represented in the cumulative frequency curves below. Cumulative frequency curves for the diameters of gold spheres produced by machine A and B. That's the figure below. And our first question says, determine the interquartile range for the diameters of gold spheres produced by machine A. So here we're looking for the interquartile range, which is the third quartile minus the first quartile. And that would be IQR is equals to Q3 minus Q1. Then we have to first figure out what Q3 and Q1 is. Starting with Q1. Q1 will be the value at quarter of the cumulative frequency. So a quarter of the cumulative frequency, here we see that the cumulative frequency goes up to 400. So over here is our value, and we'll multiply that by 400, but we can already tell that here it's divided up into 4 sections. So each represents a quarter. This is 1 quarter, 2 quarters, 3 quarters, and 4 quarters. So if you know it like that, then it also becomes easier. You can either do the calculations or look at it visually. But here we'll see that our interquartile range happens at 100. But this is not the value that we are looking for. So in order to get the actual first quartile, we have to take our value and trace it to machine A, which would be the blue graph, and then read off the value at the x-axis. So in this case the diameter, which in this case would be 5.8 millimeters, if you will. Then Q3, the third quartile, would be 3 over 4 times 400, which would also now be 300. And we would then find, again, we trace it to machine A and then take it down to read off the value at the x-axis. In this case we see that it is 6.0 millimeters. And then to find our interquartile range, we just subtract these two values. So 6.0 millimeters minus 5.8 millimeters. This will give us 0.2 millimeters. This is your interquartile range.